Problem number 1. Find the integral dx over x minus x squared. In this problem, if we look at the integrand 1 over x minus x squared, the denominator x minus x squared can be factored as the product of x and 1 minus x. Because of that, we should include one partial fraction for each factor and write 1 over x minus x squared as a over x plus b over x minus 1. That does be equation number 1, where a and b are constants that are to be determined. Now we're going to multiply equation number 1 by the least common denominator, and that is going to give us the basic equation 1 is equals to a times 1 minus x plus x times b. We can substitute any suitable values for x to get the equation in a and b, because this equation must hold for all x. The most effective values are those that brings the particular factors to a value of 0. So to solve for a, let x equals to 0 to get 1 is equals to 1 minus 0 times a plus 0 times b, and that gives us a equals to 1. To solve for b, similarly, we take x is equals to 1, so that is going to give us 1 equals to 1 minus 1 times a plus 1 times b, and solving this we get b is equals to 1. So it follows that the decomposition now becomes 1 over x minus x squared is equals to 1 over x plus 1 over 1 minus x. So it follows that integration of dx over x minus x squared will be equals to integral dx over x plus integral dx over 1 minus x. The integration of 1 over x gives us the natural log of x, and integration of 1 over 1 minus x is going to give us negative log of 1 minus x plus the constant of integration c. Problem number 2. So here we need to determine the integral x squared dx over x plus 1 times x plus 2 times x plus 3. So we are going to consider the integral x squared over x plus 1 times x plus 2 times x plus 3, and then we're going to decompose into 3 partial fractions as a over x plus 1 plus b over x plus 2 plus c over x plus 3. Let this be equation number 1. Then we're going to multiply each side of equation number 1 with the least common denominator, x plus 1 times x plus 2 times x plus 3, and that gives us the basic equation x squared is equals to x plus 2 times x plus 3 times a plus x plus 1 times x plus 3 times b plus x plus 1 times x plus 2 times c. Now in order to obtain a, b and c, we're going to substitute the value of x with negative 1, negative 2 and negative 3 respectively, such that we get a equals to half, b is equals to negative 4 and c is equals to 9 over 2. The decomposition given in equation number 1 can now be rewritten as 1 over 2 times x plus 1 minus 4 over x plus 2 plus 9 over 2 times x plus 3. Then we integrate it, both sides with respect to x, and that should give us half integral of dx over x minus 4 times the integration of dx over x plus 2 plus 9 over 2 times integration of dx over x plus 3. The result will be half of the integration of dx over x is going to be the natural log of x minus 4 times the integration of dx over x plus 2 will be natural log of x plus 2 plus 9 over 2 times the natural log of x plus 3 plus the constant of integration c. Problem number 3. So here we need to find the integration of 2 minus x over 1 minus x squared with respect to x. Because the denominator 1 minus x squared can be written as the product of 1 minus x and 1 plus x, so we should include one partial fraction for each factor and write the integrand 2 minus x over 1 minus x squared as a over 1 minus x plus b over 1 plus x. Let this be equation number 1. Now we are going to multiply each side of equation number 1 with the least common denominator 1 minus x squared, and that should give us 2 minus x is equals to 1 plus x times a plus 1 minus x times b. Now in order to find a, let x be equals to 1, and then that should give us 2 minus 1 is equals to 1 plus 1 times a, which gives a value as half. To find b, we're going to suppose that x is equals to negative 1, and that gives us 2 minus of minus 1 equals to 1 minus of minus 1 times b. Solving for b, we get 3 over 2, such that our decomposition now becomes 2 minus x over 1 minus x squared will be equals to 1 over 2 times 1 minus x plus 3 over 2 times 1 plus x. Then we are going to integrate it with respect to x, so that should give us half integral of dx over 1 minus x plus 3 over 2 times the integration of dx over 1 plus x. The first integral will be negative half log of 1 minus x plus 3 over 2 times the natural log of 1 plus x plus the constant of integration c. Problem number 4. Find the integration of dx over x times x plus 1 whole squared. So we consider the integrand 1 over x times x plus 1 whole square and decompose it into 3 partial fractions. So there will be 3 partial fractions because we have a repeated factor x plus 1 in the denominator. So we get a over x plus b over x plus 1 plus c over x plus 1 whole squared. Let this be equation number 1. Then we multiply each side of equation number 1 with the least common denominator, that is x times x plus 1 whole squared, which will give us 1 is equals to x plus 1 whole squared times a plus x plus 1 times b plus x times c. Then we will simplify this equation, so that should give us 1 is equals to x squared plus 2x plus 1 times a plus x squared times x times b plus x times c. Now we are going to write all the like terms together, so that will be x squared times a plus b plus 2a plus b plus c plus a. Using this equation, we're going to equate both sides to get the value of a, b and c. So that should give us a plus b is equals to 0 because the coefficient of x squared on the left hand side is 0. Solving for a, we have a equals to negative b. And the second equation will be 2a plus b plus c is equals to 0 because we have equated the coefficient of x as equals to 0. Then we can rewrite this equation as a plus b plus c is equals to 0, so that we can replace a plus b with 0. That gives us a plus 0 plus c is equals to a. Solving for c, we have negative a. And finally, the third equation will be a is equals to the constant 1. Now, using the value of a, we have b will be equals to negative 1 and c will be equals to negative 1. Such that our partial fraction 1 over x times x plus 1 whole squared will be equals to 1 over x minus 1 over x plus 1 minus 1 over x plus 1 whole squared. Then we integrate it with respect to x. So dx over x times x plus 1 whole squared will be integration of dx over x minus integration of dx over x plus 1 minus integration of dx over x plus 1 whole squared. That will give us natural log of x minus natural log of x plus 1 minus of minus 1 over x plus 1 plus the constant of integration. And finally, we have natural log of x minus natural log of x plus 1 plus 1 over x plus 1 plus c. Problem number 5. Here we have to find the integration of dp over p times 1 minus p squared. Because p times 1 minus p squared is equals to p times 1 minus p times 1 plus p, we should include one partial fraction for each factor and write 1 over p times 1 minus p squared as I over p plus b over 1 minus p plus c over 1 plus p. Let this be equation number 1, where a b, and c are constants that are to be determined. And we're going to multiply each side of equation 1 by the least common denominator p times 1 minus p squared to get 1 is equals to 1 minus p times 1 plus p times a plus p times 1 plus p times b plus p times 1 minus p times c. Now let p be equals to 0 to get a is equals to 1, p be equals to 1 to get b equals to half, and substitute p with -1 to get c value as -half. The decomposition function then becomes 1 over p times 1 minus p squared is equals to 1 over p plus 1 over 2 times 1 minus p -1 over 2 times 1 plus p, integrating both sides with respect to p. So we have integration of dp over p plus half times the integration of dp over 1 minus p minus half of integration of dp over 1 plus p, such that we get natural log of p minus half of natural log of 1 minus p minus half of natural log of 1 plus p plus the constant of integration c. Problem number 6. Find integration of dx over e raised to the power of x minus 1 whole squared. Before delving into this problem, we're going to multiply the numerator and denominator by e raised to the power of x to get integration of e raised to the power of x dx divided by e raised to the power of x times e raised to the power of x minus 1 whole squared. So let this be equation number 1. Now we're going to do the method of substitution and substitute e raised to the power of x minus 1 with t, and differentiating it both sides with respect to x gives us e raised to the power of x dx is equals to dt. So e raised to the power of x minus 1 is equals to t can be rewritten as e raised to the power of x is equals to 1 plus t, such that our integral now becomes integration of dt. So we replace e raised to the power of x dx with dt divided by e raised to the power of x will get replaced with 1 plus t times t squared. So let this be equation number 2. So what we have a new integral, and we are going to decompose the integral 1 over 1 plus t times t squared into 3 partial fractions, which can be written as a over 1 plus t plus b over t plus c over t squared. Now multiplying both sides with the least common denominator, that is 1 plus t times t squared, we get 1 is equals to t squared times a plus t times 1 plus t times b plus 1 plus t times c. Now we're going to write all the common terms together. For that we need to reduce the expression on the right hand side. So we have t squared times a plus t times t squared times b plus c times t c. That should give us t squared times I plus b. This will be the coefficient of t squared plus t times b plus c, which will be the coefficient of t plus c. Now we are going to equate both sides. That should give us a plus b is equals to 0 because the coefficient of t squared on the left hand side is 0. Similarly, b plus c is equals to 0 and c is equals to 1. Solving for a, b and c, we get a is equals to -1, b is equals to -1 and c is equals to 1, such that our decomposition function or the partial fraction becomes 1 over 1 plus t times t squared is equals to 1 over 1 plus t minus 1 over t plus 1 over t squared. Integrating both sides with respect to t, we have integration of dt over 1 plus t times t squared is equals to integration of dt over 1 plus t minus integration of dt over t plus integration of dt over t squared, which finally gives us the natural log of 1 plus t minus the natural log of t minus 1 over t plus c. And finally, we have to replace the value of t with the original function e raised to the power of x minus 1. So that should give us natural log of e raised to the power of x minus natural log of e raised to the power of x minus 1 minus 1 over e raised to the power of x minus 1 plus the constant of integration c. Problem number 7. Here we have to find the integration d lambda over lambda times lambda squared plus 1. We are going to decompose the integrand 1 over lambda times lambda squared plus 1 as a over lambda plus, now here we can see here that in the denominator we have a quadratic term, lambda squared plus 1. The second partial fraction will be b times lambda plus c divided by lambda squared plus 1. Now we're going to multiply throughout with the least common denominator, lambda times lambda squared plus 1, which will give us 1 is equals to lambda squared plus 1 times a plus lambda times b lambda plus c. That will be equals to lambda squared a plus lambda squared b plus lambda times c. Writing the common terms together, we have lambda squared times a plus b plus lambda times c plus a. On the right hand side we have 1, so which can be rewritten as 0 lambda squared plus 0 times lambda plus 1. Equating both sides, and that will give us a plus b is equals to 0, such that a is equals to negative b, c will be equals to 0, and a will be equals to 1. Now using the value of a equals to 1, we have b is equals to negative 1. So our decomposition function 1 over lambda times lambda squared plus 1 now becomes 1 over lambda plus negative 1 times lambda plus 0 over lambda squared plus 1, or 1 over lambda minus lambda over lambda squared plus 1. Now we integrate both sides with respect to lambda, then that will give us integration of d lambda over lambda times lambda squared plus 1 is equals to integration of d lambda over lambda minus integration of lambda over lambda squared plus 1 times d lambda. To find the value of the second integral, what we're going to do, we're going to multiply and divide by 2 so that we can use the method of substitution. Now finally we get natural log of lambda minus half times the natural log of lambda squared plus 1 plus the constant of integration c.